So I'm excited to introduce Jason Kierstead, who is coming to us from IBM. And what I was most interested in about this submission was not just the concept of a platypus, which, let's face it, I mean that's going to get attention when you see that come up in your CFP submissions, but was actually his role, an architect of threat management. And he's, as I said, at IBM, and managing the threat lifecycle is something that a lot of us don't think of at first when we think of threat hunting, because you think of threat hunting as the activity that we're going to do, going out and searching for activity or artifacts in our logs or in other evidence. However, threat management brings this into a much broader picture. So I'm really excited to hear this talk specifically because we're talking about data modeling, information modeling here, talking about how to deal with the threat as an entity instead of the hunt as just an activity. So with that all said, I'm very excited to turn this over to Jason, and excited to hear more about the platypus as well. So take it away, sir.
Okay, thanks a lot, Phil. My name's Jason Kierstead, widely known in some communities as JK. I'm the CTO of Threat Management for IBM Security, as Phil mentioned, and I help drive the technical direction of our whole portfolio in threat detection and response. I'm also the co-chair of the Open Cybersecurity Alliance Project Governing Board. And first, I want to thank you guys all for taking a few minutes out of your day to listen to me ramble on about information modeling. What is it exactly? Why should you care about it? Common challenges that I see associated with it. And I hope to share a few ideas on how to overcome some of those challenges. A couple of the different angles that I'm going to talk about may not necessarily be new news to some folks, but I can tell you from my experience dealing with Fortune 100 class organizations all over the place that there is still a very long journey ahead in this specific space around information modeling if we want to get things to where I believe we need them to be in the industry. And along the way, we'll learn a little bit about biology perhaps as well, and the platypus and whatnot. Although I want to make it very clear, everyone, I don't claim to be a biologist in any sense of the word. So I want to start this talk off with a quote that I really like. It's called, "There is no AI without IA." And in this context, IA stands for information architecture. A number of different people have said this over the years, but the earliest reference I could ever find to this is by an AI expert. His name's Seth Early, and he said this in 2016. What this quote is referring to is the importance of having a well-defined information architecture if you ever want to be able to do something as complicated as machine learning. It's not an optional step, I'd argue, when you're trying to develop machine learning, and it's also not an optional step if you want to do anything advanced in cybersecurity. Why? It's pretty simple. You can't teach something that you don't already understand yourself. And that holds as much true as much for machines as it does for people. And this whole idea of understanding your data, understanding what it looks like, what it feels like, what it smells like, is really fundamental to building a cybersecurity information architecture. So just let's set some table stakes first. What is an information architecture? JK, what are you talking about? In short, information architecture is the design and organization of information so that it can reliably support things like findability, usability, analytics, takes into account data curation, validating the data. In some cases, not really relevant for cybersecurity, but it takes into account translation, normalizing the data, cleansing the data. Without a proper information architecture around your data, it tends to not look the same. It can be stored in different places, different APIs to query it. There's different models of the data. It becomes very hard to work with, and things like building analytics and machine learning on top of that data gets very difficult. So my question is, does this sound familiar to you? Because to me, this is the world that we live in every day in cybersecurity operations. We run into this stuff when we're ingesting data, when we're correlating it, when we're hunting, when we're responding to incidents, because none of the tools in our huge arsenal, they don't tend to speak the same language. The log sources don't tend to look the same. The analytics don't work from tool to tool. Everyone's speaking a different language. And it's it's one of the root problems of a lot of challenges in cybersecurity. It's why extracting, real actionable value from something like a large SIM or data lake can be so hard. It's why analysts, who's become an expert in one tool chain, can't necessarily easily port those skills over to another, which then plays into, we hear a lot about this mythical, well, depending on who you talk to, mythical cybersecurity skills gap. This is a big part of it, right? When your skills are not easily portable from tool to tool and from employer to employer, it makes the overall talent pool a lot smaller. So I want to start this with a better understanding of how information architectures work by tying it to an information architecture that I think many would be at least somewhat peripherally familiar with, and that's taxonomy and biology. Taxonomy is basically the science of creating an IA for all life on Earth. Why do we need a taxonomy for life? Why was this thing ever developed? It's simple, really. As humans, we really, really, really like to group things to explain them to each other. In fact, this whole science of taxonomy, it's been referred to before as the world's oldest profession, apparently by people who aren't familiar with the other world's oldest profession. But the point is, we've been doing this for a millennia. Modern taxonomy, however, it traces back to about 1735 by the Swedish botanist named Carl Linnaeus developed it. So I want you to think about how important taxonomy is to this area of science. Imagine you went to an island and discovered a new creature, and you had to describe that creature to someone. If you didn't have taxonomy, if you didn't have a common way to talk about what that animal's characteristics are, the whole conversation would become extremely challenging. And that's why information architecture is so important. If you don't have a roughly agreed upon information architecture, it's not possible to have proper communications. Now, I'm not going to spend an inordinate amount of time on this whole idea of biology and taxonomy in this talk, so don't be worried too much here. But on the left, you can see the rough hierarchy of taxonomy with groupings that you're probably at least peripherally familiar with. Note earlier, however, that I said rough agreement on information architecture. And the reason that that's important is because even in an incredibly mature domain like biology, something that's been around for hundreds of years, as I said, traces back 1735, there's still today a continual evolution in this information architecture. Multiple taxonomies can often be in use by subsets of this community until over time, the architectures come to a consensus and start to converge. Below, you can see a rough timeline I created by doing some research around this. These are at the domain and kingdom level, what you see here in the slide. That's the absolute bottom level of the previous pyramid. So, think about how interesting this is that, we're still trying to sort out hundreds and hundreds of years after the science was created what the most basic high-level groupings of life should be. And that's because we're constantly learning and discovering new features of microorganisms and whatnot. I find this whole thing fascinating, but I can already kind of hear what you guys are thinking. Thanks a lot, Dr. Science, but what on earth does all this have to do with threat hunting and cybersecurity? So I'll tell you what it has to do with cybersecurity. It's because when we're hunting and when we're developing detections, we really want to detect things, not strings. And I love this quote, this idea of things, not strings, and we're going to come back to this a couple of different times. So we just spent a bunch of time talking about these information models, what they are, and now I'm going to tell you why they're vital in cybersecurity. First of all, let's talk about the normalization of data. Why is normalizing data important? Well, I talked about this a little bit when I was talking about information architectures, but to recap, First of all, there's no widely adopted standard for security event logging. Nothing that, nada. I've been at the focus of this whole area of the industry for about 15 years, and I can tell you we're barely further ahead today than we were even 15 years ago. It's still the total Wild West. Why is this? It's a combination of different factors. There's a lack of market pressure, there's developer complacency, and a bunch of other things at play. But there's a silver lining here, and that's cloud. Cloud is helping a little bit because of when you build detections against the cloud, the major cloud vendors are somewhat normalizing that data because so many things are built on top of their APIs. So that's, a little bit of a cost, right? We're coming to normalization, but it's at the cost of over-centralization. Second point here, and it contradicts the first a little bit, and that's that public cloud vendors can't and likely will never agree on what their data should look like when you pull it out of them. Their platform-specific security tools that they build against these clouds, they don't tend to agree on data formats and what the data coming out of them is supposed to look like. And it's unlikely they'll ever agree because, frankly, there's little pressure in the marketplace for them to do this. As such, you've kind of got this situation where you've got momentum towards the market improvement, like I talked about before, but it's at the cost of this known ceiling on how well this is ever going to end up, because those 3 to 4 major public cloud vendors are unlikely to produce. Another reason that this is important is sunk cost in existing detection analytics. So when you've spent a lot of time, money, and effort building detections, that's a sunk cost that you don't want to waste. And finally, we all have to recognize that this same cybersecurity startup culture that rewards the churning out of innovation all the time, it doesn't necessarily weigh enough on long-term supportability and things like using existing data models to make sure that your tools work properly with all of the others. So why is normalizing data something that you would need when you're developing hunts and detections? First, there's extensibility. If you build your detections and analytics on a normalized data model, it's a lot easier to combine and mix those detections into new ones because all the detections share the same underlying data model. Second is this idea of portability and reuse. The ability to have your detections and skills be able to move from data source to data source and tool to tool, it's incredibly valuable and can save you a lot of time when you're doing investigations. This also plays into the earlier skills gap area that we mentioned earlier and widening that talent pool. Finally, we've got collaboration. Thankfully, we're starting to see an incredibly increased movement around community development of detections. I can't be more pleased that we're finally starting to see this after a lot of years. Collaboration around analytics and detections, however, it's really difficult if everyone in a certain community aren't speaking the same language because they're not using the same tools and then the same tool chain and their data looks different. So that can sometimes lead to folks not being able to equally participate because they don't use the same data models, and the power of the crowd is then diminished in that case. So all of that sounds great and interesting. This is a really important thing to do, but I'll tell you, it's a lot easier said than done. In practice, there's many real world challenges that you're going to face in this whole area of trying to align your data to an information architecture. So let's start going over those, and we'll start with some of the basics. First of all, if you're going to try to align to a data model, which one should you be trying to align to? There are a lot of different information models that exist in cybersecurity. Some of them are here on the slide, but there's actually a lot more than these. And each one of these is a data model that you can map your data to and from in order to normalize it. Why do so many of these exist? Well, I'm sure people are familiar with this XKCD comic, which I pull out very often. This whole one about the standards and how they proliferate. But in all seriousness, we could pontificate all day about how we got to this place and why we continue to have new and more models and can't get to a consensus. But the fact is, all these models are out there and they are popular in their own domains and they have very important use cases. So they're not going anywhere anytime soon. There's not going to be like this massive consolidation of data models. It's just a pipe dream. So getting back to the question, how do you choose? First of all, I'm not going to spend a lot of time going through all the minutia, comparing and contrasting all of these models. I was originally thinking about doing some of that in this talk, but then I realized I only have 25 minutes and that would probably take us all day. So instead, I want to talk more at a high level about how to choose a model that you want to map your data to and what things you got to think about. First, do you have any influence at all on the source data? I still run across people who don't necessarily realize this, that it is possible to change the output formats and data models of many different cybersecurity tools. And if you have the ability to influence that inside your environment, if you can ask them to change the data format on these devices and these sensors before it gets to you, it can be incredibly useful and incredibly powerful to exert some of that influence and achieve that alignment. The second thing to think about is, what is your tool chain? Does your tool chain work best with a preferred data model? I'm going to pick on Elasticsearch here for a second because it's an extremely popular open source tool in this community. And Elastic last year released this ECS data model, which is incredibly powerful. Yet, I still don't see a huge uptake of it in the cybersecurity community. And this is something I'd really like to see more threat hunters and more folks who are standing up elk stacks take a much closer look at. People are still somewhat blindly throwing all their data into Elasticsearch and then trying to extract value out of it on the other side. And if a little bit of effort can be spent on that data curation in advance to map it to something like ECS, you can reap enormous rewards from it. Second thing to think about is, what are your use cases? The best path and model on how you should do things for real-time detections, it might not be what you want to do for threat hunting. One thing I'd caution though is that when you're looking at all this stuff, keep in mind that if you start at one, you're probably going to end up wanting to use this data for the other use case. So really, from the start, if at all possible, you should be trying to take into account both real-time detection and incident response and threat hunting when you're doing this exercise. What's the level of expertise in your organization? If everyone on your team is a wizard with CIM, then not using that as your standard model, obviously doesn't make a lot of sense, because, it's going to be a huge lift for you to go and retrain, a whole slew of people. What are your use cases? Finally, back to the power of the crowd, are there communities that your team is involved with that you plan to leverage? If those communities exist, where's their expertise? What models are most popular in that community? This is something that's very important. Do you have existing content or analytics you want to leverage? Or do you plan to, mainly base this around a community? So let's pivot back a little bit to the whole biology point. And, this is, I hope, a little bit of a fun exercise that illustrates a second challenge you're going to face on this journey. This is a picture of a platypus. So if you think back to our earlier conversation on taxonomy, how do you think the platypus ends up getting classified? It's a mammal, right? It's obviously a mammal. It has fur, it produces milk. Wait, maybe it's a bird. After all, birds lay eggs, they have a bill. Wait a second. he's got poisonous spikes, and he has an electrosensory system. Those are typically characteristics of a reptile. You know, how was it classified when it was first discovered? It's totally non-obvious what this animal should be. And the only real solution to try to figure out what it is to model all of its attributes according to your taxonomy model and see where it falls according to your information architecture. You can't just take like a wild swag at it and expect it to come up with good results. So what does this have to do with threat hunting? And by the way, for anyone actually interested, the platypus is a mammal. So what does this have to do with threat hunting? So hopefully, you know, a lot of folks will recognize what this is on the screen. This is just a typical Microsoft Sysmon event. That's pretty obvious. My question is a little bit more fundamental than that, though. How do you model this data? And to be clear, you know, this is nothing interesting. This is just the Sysmon event I grabbed from a quick Google query to build this presentation. It's nothing exciting. But what is this? The answer is it's not any one type of data. It has lots of different features. It's an endpoint log. It's a log of process activity. It's a network flow. It's also a file record. It's all of these things at the same time. What it isn't, however, is Windows Event ID 3. And, you know, technically it is Windows Event ID 3, but that is actually the most unimportant piece of data here, despite the fact that detecting and searching based on Windows Event ID, it's one of the most commonly referenced things when people are talking about detections and investigations. You know, oh, you want to go and look for this activity. You're looking for Windows Event 285 or whatever. Remember earlier when I mentioned we want to find things, not strings. And this is why this conversation is important. And it's really the crux of this entire talk. If we're doing threat hunting, looking for things like, say, specific Windows Event IDs, and I don't want to focus too much on Windows Event ID, but there's a number of different things of this nature. If we're looking for not the data that's in the record, but we're looking for the record itself, then we've lost all of the benefits of modeling the data in the first place. Suppose for a second that this TTP, whatever's going on in the Sysmon event, this TTP, had been involved in a virtual machine, and it was recorded by a cloud workload protection solution instead of Sysmon, and you got the data that way. You've got the same process. It's doing the same things. It's aggressing to the same network location. But because it's not coming from Sysmon anymore, the data is going to look very different. And if you had built a bunch of detections or hunts around the Sysmon event, none of them are going to pick that up, just because you're now getting that information from a different tool. And that's really the crux of this when we talk about things, not strings. You know, you really want to be looking for the data as modeled, not the raw data itself. It does not do to leave a live dragon out of your calculations if you live near him. What does this quote mean? It means that factoring in a highly probable future scenario, even if that scenario isn't really assured, is something that's very prudent to do. In other words, take a beat to plan ahead. When you're building your detections, when you're working on your hunting playbooks, take some time, try to build those things around a well-defined data model instead of the raw data, if at all possible. If you can do that, over time, you're going to reap major dividends in your environment. Finally, a couple of best practice guidelines. Some of these things are a little bit basic, and some people in this talk may have heard these things a million times. But on the other hand, you know, as I mentioned at the beginning of this, I still see in Fortune 100 level organizations, there's so many people still struggling with some of these basics. So I don't mind repeating them. First of all, try to make your detections generic. Look for the TTPs if you can. Don't look just at the IOCs. Another way to talk about this is look for the payload, not the envelope. It's another way to say the whole things not strings conversation. We want to look for that actual model data, not the envelope it's been delivered in. Look for threat signals, not OS signals. What do I mean by this? You know, TTPs, increasingly, you can figure out ways to do this that are platform and OS agnostic. And, you know, while this is a little bit more rare, that a given TTP can, you know, cross OS boundaries, as we migrate to increasingly virtual environments and our applications are all delivered to us via the cloud, you know, we're, as an example, right now with COVID, there's an enormous uptake in remote work and remotely delivered applications that are running on single purpose VMs and shipped off to the endpoints. So as you start to look in this world, you know, it's going to become more and more important because the ways that you get visibility in these environments are very different. And if you're doing things with blinders on, trying to build things with platform specific use cases, it can really limit your whole visibility. Finally, you know, test. This is always best practice for pretty much anything you ever do in a technical area. But, you know, echo it again for detections, you have to test detections like crazy. And then again, you know, planning ahead, taking shortcuts in this area, you know, it's usually ends up you having to go back and redo it later at some point in time, either as you grow or as you onboard new tools or what have you. So, and you know, and some of this data, you want to keep it for a long time, right? So having to go back and remodel that data is painful. So what's the next frontier? Before I wrap this up, I want to outline something that I see as the future, and that's not just a common data model, but common hunting and analytics languages themselves. Why do we need this? It's the same reasons that we were looking at common information architectures. You know, lack of folks that have the right skills, you know, this enormous volume of data that's coming out of the cloud, this need for collaboration around detections and analytics in the community. Being able to detect things and write hunting playbooks and express complex analytics in one open source language that you could then use on any different cybersecurity tool chain, that's now a world where you can have ultimate reuse and ultimate community collaboration, because everyone can start cooperating on next level detections and next level use cases without worrying about whether or not this complicated query that is going to work in this SIM or the other SIM or this XDR tool, or, you know, against this data that's running in this Elasticsearch cluster. This kind of may sound a little bit too good to be true, but I don't believe that it is. We're very rapidly approaching this case. There's a lot of momentum in the space, and there's some exciting things that are going on in this area. And I strongly implore everyone to, you know, take a look at what is out there and what's going on, because it's very exciting. To close, I'm going to leave you with a few different resources you can draw on if this whole topic was interesting to you, if you want to dive into the space more. First, I recommend checking out, you know, Uncoder.io and the Sigma project that, you know, some folks earlier today were talking with Sigma. If you're not familiar with it, it's a very powerful tool in this domain. Although it maps a little bit more into the detection space, you can actually also use it when you're hunting. Next, I'd be remiss if I didn't call out our own Stick Shifter project in the Open Cybersecurity Alliance. Stick Shifter is trying to solve for a lot of these same challenges that I outlined in this presentation. And it's trying to do that by getting you to a place that you don't have to worry so much about the data model you ingest, because it's up-leveling that problem up to the analytics layer. I also mentioned Elastic Common Schema. If you're using Elasticsearch in your organization in any way, and you're not using Elastic Common Schema, you know, you don't know what you're missing. So take a look at that. Finally, check out the MITRE CAR project. CAR, for folks who don't know, stands for Cyber Analytics Repository. This is an effort by MITRE to build one of their own aforementioned communities for detections. And CAR actually has its own data model as well, although a lot of the detections in that community also have mappings to other data models, not just CAR. And with that, I'm going to wrap. And thank you very much for taking the time. I hope you enjoyed me pontificating about data modeling and platypuses and a bunch of other stuff. If you have any questions or want to follow up on this topic or anything else, I'm very easy to find on Twitter or LinkedIn, and I'm going to be in the Slack channel here for a little while as well.